Hi everybody, we will start shortly. Okay, we can start. Today, what we're doing today? I think today we are doing some algorithmic research again, back from coding interviews yesterday. Let's start with some code forces and blog posts. We have 3 streams this week. First one being yesterday, and the third one will be Friday. Algo research and writing all the editorials. Yeah, that's what I'm going to do. And let's start by modifying Twitch description. With a correct link to the video. And the description will be that. Okay. And we're good to go. I see somebody dig up my old blog. For the 9th question of EV easy problems is the answer to the problem EV of the number of matches won by the winner of the whole tournament, blah blah. Let's see. And the probability that Poland will win the whole tournament, find the EV of the number of matches won by Poland. Find EV of the number of matches won by Poland, assuming they won the whole tournament. Is the answer to the EV of number won by the winner of the whole tournament 29/6. Hello, João Ribeiro. Sorry if I mispronounce your name. There's here a video, and I guess there should be timestamps available. (19/12). I'm opening that without sound, so I'm not sure what is being said. Maybe I will cheat a little bit. I don't remember. There is a video with timestamps. Which problem? Okay, I'm not sure if there's that problem described as well, but then he will tell me that. Hello, Uprit as well. Good morning. What else we have in code forces? Rating decay. Kostka had an idea that your rating should decrease when you're not competing in rounds. So like slowly every month it should decrease by a small value to fight with inflation. I think it's a fine idea, maybe not necessarily very important. Somebody brought a point that in games like Overwatch, Heart of the Storm, you can play anytime. In Code Forces, maybe you want to participate, but you will miss several rounds. And here the point is, I'm assuming one can play a game at any time, but for contests you can just sit at your preferred time. So it's bad to penalize people that can't participate for several weeks. It causes rating inflation. So people who do not participate anymore are effectively not a part of the rating ecosystem if they don't participate. They don't affect rating redistribution in any way. Okay. By the way, there was a code jam round recently, and I was asked in Code Forces in private messages how to solve some problem from this round. I told the guy to look at the editorial, and he said where are editorials, what shows how not intuitive their current interface is. To see editorials for the round, you must open a problem like this one, and then I see my submissions, I see the statement, and between them here with like gray font there is problem and analysis on the right. You must see this button, and there is then analysis. That's very, very stupid. Just it's badly made. Let's think. I want to for sure today do editorials for ROI, this one. So I'm lucky editorial to Robo Marathon. We can start with that and then move to reading about algorithms. And in Emacs do we have here something that is worth reading? Joseph's problem, 15 puzzle game, existence of the solution. Okay, what about this? Why is there solution to 15 puzzle game? The rules of the game are, or the puzzle. The game is played on 4x4 board. On this board there are 15 playing tiles. One cell is empty. You need to get the board to the position presented below. So sort the numbers. Let's Google how it looks like. It looks like that, and you can, in this case, move 7 down or move 13 to the right. Existence of the solution. We want to prove that it's possible to solve it. I guess it's I thought there are two classes of arrangements, just like in Rubik's Cube. If you pull one tile out and you put it in a different place, you might change the parity, and it won't be possible anymore to finish the cube, Rubik's Cube. Let n be the number of inversions in this permutation. So we look at numbers a1, a2, and so on. Let n be the number of inversions in this permutation. Suppose k is an index of a row where the empty element is located. The solution exists if and only if n plus k is even. Proof. In 1879, Johnson proved that if n plus k is odd, then the solution doesn't exist. And in the same year, Story proved that all positions when n plus k is even have a solution. However, all these proofs were quite complex. So that's not a valuable article if they just say, okay, their proofs are complicated. Here, simpler proof with a link. Is it long? Wait, so here we start with generalizations. The proof, I guess, lasts to this moment. Solution. Introduction is up to here, and then solution is 1 page to 2.5. Not so bad. I want to just scroll through to see what it does, more or less. Every move of the blank block affects a permutation on the slots occupied by the blocks. For example, that. Lemma. For n up greater or equal 3 cycles, generate a of n. Consecutive 3 cycles, the cycles. Okay. I don't want to read it. It's still too long. Scheduling jobs on 2 machines. Is it dynamic programming? The task becomes NP complete if we have more than 2 machines. This is not dynamic programming. I guess it's greedy. The task is about finding an optimal schedule for n jobs on 2 machines. Every item must be first processed on the first machine and afterwards on the second one. Okay, I didn't knew. I thought that we have n jobs and we should schedule them between 2 workers. Actually, here every job should be first done on one machine, then on the other. The ith job takes AI time on the first machine and BI time on the second machine. And we should find optimal order to minimize the total time. By what we should? I guess we should sort by something. What that would be. Maybe first it would be good to put something with small AI, so that the first machine will be quickly done with the first task, and it would give it to the second machine. We can assume that the order of jobs for the first and the second machine have to coincide. In fact, since the jobs for the second machine become available after processing them at first, if there are several jobs available for the second machine, then the processing time will be equal to the sum of their BI regardless of their order. Consider the order of jobs. We denote xi the idle time of the second machine before processing task I. Our goal is to minimize the total idle time. For the first job we have that. So when first machine needs 5 seconds for the first job, and only then the second machine will take it, then the first idle time for the second machine is 5. For the second job, since it gets sent to the machine at the time that, we have this. In general, we get equation. The permutation method. We'll exchange two neighboring jobs and see how this will change the total idle time. I think this is called exchange. Whoa. It's in my blocks. What was the name? Exchange arguments? Yeah, exchange arguments, sorting with DP. If you want to read about this method, go to my blogs and find lecture 3, exchange arguments, sorting with DP. Blah, 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 and they got that we should sort by this. Minimum of aj and bj plus 1 is smaller or equal than that. Actually, the comparator should be smaller. We can further simplify the sorting. Thus, we can sort the jobs by minimum of ai, bi. If the processing time of the current job on the first machine is less than the processing time on the second machine, then this job must be done before all the remaining jobs. Yep. I think I did similar problem in that block. Not sure about it. No, I don't see. I guess it's similar to the hero problem about monsters. Implementation. Well, implementation is trivial. There's just general technique for those problems. And apparently for 3 machines this is already NP hard. Do that. Just definition and how to solve it. Maybe I should read more about flows. I don't know them well. Second best minimum spanning tree, I've checked that one the last time. Kirchhoff's theorem, it was the one with matrices. You're given a connected undirected graph with possible multiple edges represented using an adjacency matrix. Find the number of different spanning trees of this graph. I think it was determinant of the matrix. Yeah. Matrix tree theorem. Population matrix. It is possible to show using Ohm's law, and I don't know it, and that resistance between 2 points of the circuit is that. Okay, I'm not good in physics, so maybe I will switch here to Polish so I would know words. Maybe here. Current True. A conductor is directly proportional to voltage. What is it? Okay. Where else would I read about hard algorithms that I might not know? In Codeforces. Now, how to find recent hard like educational blogs. I'm not sure about it. AtCoder 758. Okay, it was some old round. Debugging graphs with ease. Experimental Visual Studio plugin. Some Visual Studio extension. That's a cool thing. I don't know. I don't use Microsoft Visual Studio though. Visual Studio is just for Microsoft, right? Yeah. More contest, please. The closest contest is Globe Around. Can you prepare more contests for improve our coding? Preparing contests requires serious work. I'm sure people at Codeforces are working as hard as they can to frequently deliver quality contests. Yeah, if you want to practice, there are thousands of problems already. There are 600 rounds of Codeforces already. I'm sure that guy didn't do all of them. Contests, maybe here. He participated in 8 contests. But he only started an account 2 months ago. At least 2 months ago. Submissions. Between 4th of May and 12th of May, he didn't submit anything. What's happening to AtCoder? Yesterday's ABC at AtCoder was the second successive contest which suffered due to slow servers, which is fine. So ABC at AtCoder is the name of their AtCoder beginner contest. Admins didn't even care to announce if the contest is rated or not, and ignored messages. The reason is obvious. That's because of inflation in number of participants. In April, AtCoder was funded $2.7 million AtCoder. I wonder if it means they will invite more people to their AtCoder World Finals. Or was it World Tour Finals, I think? Yeah, it was that. Some contest. How do you guys balance job with competitive programming? I've already answered that blog, but let's read through that. I'm about to get out of my university and step into the corporate world. In India, most competitive programmers stop competing once they leave college. Most of them are in this game for sake of getting jobs at tech giants like Google, Microsoft, etc. However, some people never stop competing. There are some who learned competitive programming while being employed. If you are one of them who hasn't left competitive programming while working, I would request you to share your strategy. How do you balance to do both while still remaining strong during competitions? I'm just curious. In the day I work, in the night I solve problems in my dream. That's some strategy. Instead, I take part sometimes, try to do 1 contest per week on average. I don't spend time up solving problems, don't spend much time practicing except for contests. Don't get a job or make competitive programming your job. Now competitive programming is kind of my job. I'm always curious about people having full-time career in CP. I might pursue this direction in the future if I'm bored with working as big industry slaves, who knows. How does this job imply to your career progression? Do competitive programming companies like Hacker and AtCoder make enough money, and how, etc. Would very love to hear RNG's story, opinion about having a full-time career in setting competitive programming problems. HackerRank and plenty of similar websites have money because they are about coding interviews, and matching because they are about coding interviews and matching programmers with employees. You can matching programmers. Is it not a word? Programmer? No, it's fine. Matching programmers with employees. Sorry, with employers. You can does that guy live in USA? Indonesia, okay. Working for them remotely is something that will give you a lot of money, assuming you don't live in USA, assuming that you live in some poorer country. I think Poland is one of those. Working is will make you enough money, but assuming you don't live in a rich, expensive country. Looking for them will make you enough money, assuming you don't live in a rich, expensive country. So go for it if you want to work remotely. HackerRank and plenty of similar websites have many what? Lot of money. Because they are about coding interviews, maybe have money. Because they are about coding interviews and matching programmers with employers, working for them will make you enough money, assuming you don't live in a rich, expensive country, so go for it if you want to work remotely. Can prepare problems and materials, but for sure it won't be on the level of our contests, of CP contests. Okay, I think working just setting problems for the whole life is hard or impossible. Just setting problems is hard or impossible for the whole life, because you will get out of ideas the whole life. because you might run out of ideas and the will to do it, whatever. And it will stop being fun. That's true for every job. Problems for the whole life is hard or impossible because you might run out of ideas. The way to go is to become a coordinator, tester, I guess. Some people combine that with working in universities, usually doing some research. It's not reading editorial of some problems going to improve competitive programming skills. The idea is to try to do best in problem solving. By the way, do you see chat in video? There should be chat. Let me test that. Test. Test 2. Something is wrong. I need to figure it out. First, I will answer the question. It's not reading editorial of some problem going to improve competitive programming skills. The idea is to try to do best in problem solving. When I do a contest and directly reading editorial, I usually find it difficult when I want to solve that problem again in the future. Well, if you can't solve a problem, then you should read an editorial, but you should make sure you understand it. A good way to check is that you would be able to now explain that problem to someone, that solution to someone. After reading an editorial, maybe absolve it, meaning implement the solution. If you later don't know how to solve a similar problem, likely it means you didn't understand the problem fully. Okay, why the chat isn't displayed above my face, like here? Settings. Empty stream. Copy. Done. Let's try now. Test 3. Okay, looks to work. Can you write something on YouTube to test that it works as well? Maybe the font should be a bit bigger. Test 4. Okay, thanks then. Okay, I guess the font is fine. Tell me if it should be a bit bigger. Some people combine it with working in universities and usually doing some research. I'm quite sure though that you can earn more while working in big companies. You can earn more while working in big companies. And my plan is to organize classes and maybe camps, workshops. Myself, like no, not just myself, self, not alone. Is to organize classes, maybe camps, workshops myself. If you watched the stream yesterday, you know that I'm also considering something like creating a platform or course for coding interviews. And I think it would be very cool that then such a thing needs advertising, marketing, and I could just sponsor programming contests and like Codeforces rounds or camps, because my course / platform gets traction, people that know about it, and I support contests. That would be very cool to do. This topic isn't really relevant for me, as I stopped practicing 2 years ago. Started working full time half a year ago, year and a half ago. But I'm going to share my perspective anyway. Yeah, I love Tanya Romanova used to compete all the time. You can see a lot of contests here. He did all the contests, not only in Codeforces. Most of the contestants stop any sort of active training after getting a job, either because they want to do something else besides programming, or because now they have less time and prioritize other hobbies, or because they did competitive programming solely for having it on their CV. Your job is typically 40 hours a week. Let's say you need 63 more for sleep. You're left with 65 hours for everything else. There are very few students spending something at least remotely close to 40 hours per week on their studies. So typically you have more time. Yep, during university and earlier during high school you have much more time. For example, to practice competitive programming. It's hard to start later. You can easily practice 20 hours per week while having a job. I would still say that 20 hours per week is more than a lot of World Finals teams average. One of my coworkers does 20 hours per week for his endurance sports training and takes part in events like Swissman. Other one does cycling very seriously, averaging well over 20 hours per week. I guess it's about either you have more free time, you can play video games, you can meet more with your friends, or you can have a time requiring hobby. I also know people employed full time and still actively doing competitive programming. My working hours are flexible and I can take a break from almost any coding contest during the workday. What is competing for your time with competitive programming is a bunch of random stuff like watching movies or playing computer games. True. I like these kind of discussions. They won't make you better in competitive programming, like discussions like this one, but it's cool we have some community to just discuss stuff around CP with. Okay, what should I do now? Mm. 40 minutes passed already. If you don't know it, clist.by is website that has all the contests scheduled. There is AtCoder open round 2A for me in 3 a.m. So I don't think I will participate. My circuits in HackerEarth, May lunchtime in CodeJam. There is Code of Ice and Fire coding game. Maybe I will check it out. Not necessarily today. I didn't have time during the weekend. If you would like to try writing a bot for a game, then go to this website codinggame.com, and they have a game like once every 2 months or so, 3 months. This one is Game of Thrones themed. Yeah. By the way, I watched the last episode yesterday, but I don't think it's soon enough to talk about it to spoil stuff. Some people maybe haven't yet watched it, so let's wait a few days. Okay. We have ROI 2018 in Gym. There should be a link to the contest, and I don't see it, so let's add it to the blog. It should be in Gym. ROI, day 1, day 2. Link to day 1 in Gym. Day 1 in Gym, and here's a link. Links to Gym contests. Day 1 and day 2. Five hours for problems I always start scoring with subtasks. Yep. And now there are 3 problems here described. This one is very short. Yeah, but the solution was very short. And what's left is Robo Marathon. Let's finally do it. There and tracks. I will need some drawings. If you want to open it as well, I will put a link in the chat. I'm taking my graphics tablet. Okay. And we need one node. New page. Maybe let's remove that. Let's remove that. YouTube, goodbye. This is alt editorials. This is Robo Marathon. What the problem was about. I think there are n tracks. Numbered 1, 2, and so on. In each of them there is a robot. And in some positions we are putting devices, starting devices. Once there is a start, each of those starting devices, the start of the race, each of those starting devices sends a signal, and this signal is spreaded with the speed of 1 track per second, meaning that since signal and the robot in the first track are in the same track, the first robot will start moving at moment 0, but then the second one will start moving at moment 1. This one also with moment 1, at moment 1, because at that moment he gets the starting signal from the nearest device. 0, 0. Okay, and what's the problem about? For it will get to the finish line in 8 seconds. For each robot we know how much it takes him to get to the finish line, some AI. So his total time will be x being the moment where he gets the signal plus AI, the amount of time he needs to get to the finish line. For each robot determine the minimum place it can get. For each robot determine the maximum place it can get. And the easier one is p equal to 1. Means you need to determine the minimum place. The minimum place a robot can take is easier. How is it easier? I think that if we, for every robot, if we put maybe here coordinates, and now for every robot, like robot 1, robot 2, robot 3, and so on, we put here his AI, AI robots. For example, for one it will be maybe here, there, here. Then when Robo Marathon, I want to add this proofing marathon. To minimize the place taken by some robot, we should just put a starting device there. It's our choice where to put starting devices. It must be in at least one place, and we want to find the minimum place everybody can get for each robot separately. And the robot will get minimum place if we just put starting device there. If I put starting device for the first robot, he will beat, I think, for example, for this one, since the next robot starts 1 second earlier, but still here there will be a tie. I think this robot 3, can win with everybody in this area. Because like for each of those red points, they will get the same time. Red points have earlier, like they are faster, AI is smaller, but their starting signal, they will get starting signal later. Okay, so for each robot, I need to count the number of robots that have smaller index, meaning they are here, and their value of AI minus I. What is it? AI? Yeah. I'm looking to count the number of such j smaller than I, that aj minus j is smaller equal ai minus I think. This is the condition for so this way I will count points here. And then the same thing going backwards to count the number of such points below. And that's the easier part. Let's start by just no, not this one. Propose talks. Where is write a new block? Write new entry. I will put a draft here. Robo Marathon. The case p is equal 1 is easier to minimize the place of robot I. We should we should put a starting signal there. If we should put one starting device there and nowhere else. Why is the relative time the starting time of other robots compared to robot I can only be better for them, be worse for robot I. Robot I will win lose against all robots j smaller than I, that aj minus j is smaller than ai minus I. Is that correct? -1. So for j equal to 1, so the very first robot, and this value equal to 10, you would get the same situation are for robot 6 and value 15. Yes. To count such indices j, we can change each value ax to ax minus x, and then we need to know, then we have a sequence for which we want to compute for each index the number of element, the number of elements that are the number of previous elements that are greater. For which, maybe in which, for each element we want to compute the number of previous elements that are greater. Preview. The case p equal 1 is easier. To minimize the place of robot I, we should put one starting device there and nowhere else. Otherwise, the starting time of other robots compared to robot I can only be worse. Would be worse for robot I. Robot I will lose against all robots, such that I don't like this sentence. Any other scenario gives some gives all other robots the starting time is not worse than in this scenario. If we look at any other scenario gives all the robots the starting time that is not worse than in this scenario. Starting time starting time relatively to robot I it is not worse than in this scenario. Hello Drzenki. We're now I'm now writing an editorial for problem Robo Marathon from ROI 2018. Link was sent in the chat. Actually, Twitch doesn't save the chat history, but you can go to Codeforces Gym and open ROI 2018 Day 2 Robo Marathon. We should put one starting device there and nowhere else. Only other scenario gives all of the robots the starting time relative to robot I that is not worse than in this scenario. Robot I will lose against all robots j is more than I dot dot. To count such indices j, we can change each value x to dot. And then we have a sequence in which for each element we want to compute the number of previous elements that are greater. This can it will also lose against Let's focus on counting robots that will win counting robots that are earlier than I mean counting robots we need to count robots that will win against that will be faster than robot I. Let's focus on counting those with index j smaller than I, and we can reverse the sequence and repeat the algorithm. Robot I will lose against all robots j smaller than I dot this. This can be done by but what sweep line? For every element count elements smaller than that. By renumerating values to range one end and then doing a segment tree, or by sorting values and then considering them from small to big, marking their positions in the array using segment tree to know how many marked positions there are on the left. Enumerate. Okay, but that was the easier part. P equal to 1. I'm sorry, what exactly are you doing? So I think I've just answered that, right? The editorial to problem Robo Marathon. This one. Now we were left with P equal to 2, where we maximize the place. No stream on YouTube. I think we have a stream on YouTube as well. Why are you asking? It's just that for some time already I stream on Errichto 2, not Errichto 1. So I have this channel, Errichto. I want to put only short videos there, and I will move all boring programming streams from Errichto to Errichto 2. And I have Errichto 2. Where it's a new channel just for those long streams, not that well prepared. This way I don't feel bad if I do something boring on the stream. Plus, not everybody, I think, would enjoy those streams. And the main channel, I want to keep there some short educational stuff, like just talking about the problem, like for casual viewers, while this Errichto 2 is more for competitive programmers, only for them, I guess, because they will be more interested in what I'm doing. Now P equal to 2. We have okay, you have that sequence of values, and we want to maximize the place of some robot. Let's say this one. This is I. Where should I put devices? I think they will be far away from us, maybe here and there, or just on one side. Does it make sense? If they're on two sides, then it doesn't hurt to put also devices here, so that by putting more devices in this interval, I'm not changing the starting time of I. I'm only helping other robots. Should I put more devices here and there? I help all these robots by one, including actually all these robots by one, including I, so it doesn't make sense. So either that's the case, or if here's I, then maybe just put it on one side. What I think is possible, if we don't want to reward I with this value, maybe it would be good to find some examples where each of those two cases are possible and needed. Maybe only one is enough. So what if we have numbers like 5 is our I, then what here? Infinity, so it doesn't matter. And here eight, and so on, just 8. I think it's optimal to put a starting device here, and thanks to that, some guys will win against 5. I want to maximize the place of this 5, this I. So I want many guys to win against this. In this case, for sure, this is better. This case. Now, is there a case where the other scenario is better? I guess if I is roughly in the middle, here is some I, not necessarily exactly in the middle, and all the values are similar to each other. Let's say everything is 5. Then, by putting starting device here, I make those win, and by putting starting device here, I don't really change the starting time of I much, and those will win. Maybe I will lose one guy here. So this other case is also possible. We need to consider both. Where can I get started sports programming if I'm interested? What is a good place to start? I guess that depends on how good you are in maths and how good you are in programming. I think if you like books, a good introduction is Competitive Programmer's Handbook. This page, like this book, it has free PDF available online, and it talks a bit about how to do stuff in those problems usually, starting with just about input and output in C++. There is some unnecessary stuff, but maybe that's a good way to start. Then go to any platform, can be Codeforces, can be like SPOI, I would go to SPOI. This one is Polish, but there's also English version. SPOI, go to problems, sort by difficulty or what, the number of people that solved it, and start doing them. Here we read input till we find 42. It's just some input-output practice. And then there is harder and harder stuff. That's a way to start. Then you can move to harder problems. You will start reading tutorials on algorithms or read that book, and you will get better and better. Okay, we have those two cases. Let's start reading about that. Now we move to the p equal to case. Case p equal to 2. Thank you. You're welcome. To maximize robot I, to maximize the place of robot I, we should put starting devices. How is it called in the statement? Devices. Active device. Devices far away from I. Maximize the intuition is we should put devices far away from I. If we put one on track 1 or track n, if we put one on track 1 and one on track n, the starting time of I will be what minimum, like of the distances to those two devices of absolute value I minus 1 and n minus I. If I will be that. We don't affect it by putting more devices near the further of two endpoints, 1 or n. Now maybe a drawing will be good. The drawing will show the following. Maybe since the statement was like that, how to, I want to put some drawing here to show what I'm talking about. Maybe drawing is not necessary. Here I will just put it this way. I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. More devices near the further of two endpoints, 1 or n. The following, what scheme, how to call it? Scheme shows devices as in the following scheme. X denotes devices. The second way to put devices only helps other robots while not improving the situation of robot I. And this should be in pre, I think. There was some comment to not put, like to put everything monospace, yeah. In the following scheme, X denotes devices. The second way to put devices only helps other robots while not improving the situation of robot I. It doesn't make sense to put devices even closer to I, because it would improve the situation. It wouldn't improve the situation of any robot relative to relatively to robot I. So we want the difference between starting times. Okay. The other possibility is that we won't put devices on tracks. If we put one on track 1 and one on track n, later we will consider some other case. Then the starting time of I will be that. There are possibilities that we won't put devices on both 1 and n. If we put a device somewhere, it's usually better to make usually better to move it away from robot I. This way we so maybe we should put it in track 1 or in track on the track n. If we put it in one of those two, doesn't make sense to or does it? Doesn't make sense to put anything more, to put devices anywhere else. Now in the following scheme, X denote devices. No pre. I want to say that if we put it on one of those two tracks, device in one of those tracks, it doesn't make sense to put devices anywhere else. New function denotes devices. The second way is only worse for us because it improves starting time of some robots by 1, including robot I. So the place of robot I won't get worse. If we put one device on track 1 and one on track N, the starting time of I will be that. We don't affect it by putting more. The second way to put devices on the below, on the scheme below. The second way to put devices only helps out the robots while not improving the situation of robot I. Doesn't make sense to put devices even closer to I, because it wouldn't improve the situation of any robot relatively to robot I, the difference between starting times. These are version A and version B. Versions A and B are the only strategies. Maybe let's call that strategy. Or not. Oh, sorry. We need to consider. No, version B was the second one. It doesn't make sense to put device even closer to I. This is not a formal proof, but it should be enough. Now, versions. Now, how to consider those two? How to solve the problem? For every I, we need to consider this case, and we need to consider that one. I mean this one. And in those two, we need to count the number of robots that are better than I. Okay. Let's think about it similarly to what we had on the right in this drawing. And we have those two versions. Let's remove this. What was version A? What was version B? This is version. So this is version A. This is version B. In version A, if we put AI of every AI as a point with some height, now height is the value AX, so we have something like that. Oh, a blue circle. I didn't know you can put such things in the chat. We have some points and we have some I. Then who wins against I? Let's remove something from the end. Since device is at the end, everything that is more to the right is more penalized. So we just have this situation. And everybody is more penalized. No, I think the other way around. This way. Anybody here is better. Like, those win against I. And those on the left are more penalized, so it's harder for them to win. Yep. Version A can be checked. We need to implement each of them to compute a possible place of I, every I, and print the maximum for each I. Version A, robot I will be beaten by all j dot aj let's see, minus j is more than ai minus I. Version A, robot I will be beaten implement each of them, the computer possible place of every I, and then print the maximum for every I and then for every I print the maximum of computed possible places. Version A, robot I plus version A has two subversions. A has two possibilities. Putting device, the only device at the start on track 1 or track n. We need to implement each of them to compute a possible place of every I, and then for every I print the maximum of 3 computed possible places. Version A, robot I will be beaten by all j such that this. Let's check. So devices to the right, I think that's the case. So to the right you're more penalized. With the device in track 1, and I will be beaten by all. This is similar to what we had in, this is even easier than the case p equal 1. In version B, what happens in version B? For some prefix, we count version B is more complicated. Boom. Will the standings problem be similar? Okay. Now I wonder what is the easiest way to implement that. There is also, by the way, English, Russian editorial here. We can see how they do it. I don't know Russian, but it should be possible to understand something. Here we are, p equal to 2. Maybe I overcomplicated everything. Three sorted data structures are needed for AJ, for that, for that. This is Robo Marathon. Now p equal to 2. Let's see what they say about p equal to 2. Let robot I start with delay of D. Device J is turned off for all that. So for some surroundings of I, we say it's turned off. Okay, that's easier way to think about it instead of having two versions. Now n square solution. Three cases. Device 1 is on and n is off. Both devices are included. We iterate over I and one of the 3D. We consider the place. Okay. And now that n log n consider separately, let j is more than I. Okay. We need three data structures. One for aj minus j, one for this one for aj plus j, one for aj. Each should be able to answer, give me, count the number of values smaller than something. Funny. Each should be able to answer the query. Queries like the given value. In version B, we need three data structures, one for aj minus j, one for that, one for that. It should be able to answer queries like count the number of values smaller than the given value. Count the number of values smaller than the given value. So those would be this. We go from left to right. For each I, we need to answer several queries. We need to answer several queries like give me the number of indices j in some interval with value aj minus j smaller than x. The answer. We remember those. We store those queries. And then we go from left to right, then we we'll start with that. In version B, for each I, we need to answer several queries like give me the number, give me the number of indices j in some interval with value aj minus j smaller than x. Such query can be splitted. I mean, if we have some interval, we can say from 1 to this minus small prefix. Interval LR can be replaced with 1R minus 1 L minus 1. Now we need to answer only prefixes, so we go from left to right, extending the prefix one by one, and we need three data structures. One for aj minus j, one for that, one for that. To answer queries, count the number of values smaller than given x. You can actually combine this, like you can actually use this for version A2. If possible, in your solution, use bit Fenwick instead of segment 3. To get the full score. You might get around 90 with slower implementation. I think we're done. Now we can move here. Edit text, scroll to the bottom, spoiler, summary is Robo Marathon. Post. Robo Marathon, it should be Robo Marathon. Robo Marathon, and we're done. Pavel answered that 30 minutes ago. Just written tutorial. Sorry for the delay. It's so I waited like 2 months with an editorial, and when I write one, at the same moment the author Pavel Koniewski also writes his answer. Bizarre that it's bizarre that Pavel answered in the same while I was writing. After 2 months. Just reading for the this. It's bizarre that Pavel answered while I was writing it after 2 months of you waiting. Sorry again. Okay. We've done with ROI. Most annoying person on code forces. It's quite fine to visit code forces once a year and notice that things didn't change much. Okay. What happened here? Writer here. I'm going to write about how I feel about the general stances of AtCoder towards international participants. We are always short of those who can communicate in English. Hire a translator. Well, previous rounds, years ago, showed that those who just know English but nothing about competitive programming made it much worse. And the translator has to know Japanese as well. AtCoder's official announcement is terrible. They usually announce only on Twitter in Japanese. Part-time English writing staff was already offline. There are no full-time employees who dare to write in English. Why don't you do this RNG? Editorial for ABC. Generally speaking, editorials are really cost inefficient. Even if the officials don't prepare good editorials, some people write better ones. All those who are preparing the problem sets are good coders or in thread, and they don't know what is the difficult point of easy problems. Or do you still want to read? This is just a straightforward problem for all questions. So AtCoder tends to rely on the community for good editorials instead. Again, it's impossible to keep translating editorials every week. Ratism. Those who want to improve their algorithm coding skills tend to find jobs in Japan with the help of competition results. Top-level international coders who can make the contest look reputable and championship-like. As the community use Google Translate, learn Japanese. Another chance. If you can communicate in Japanese, can write English and can do programming contests, at least Orange, I think you might have a chance to work as a part-time. Their payment is good, especially if you work a lot. Apparently, admin wanted to publish an announcement, but didn't, forgot to push publish button. Okay. Boom. So Robo Marathon is done. Everything else, I guess, was done too. Looks like. I can remove that. Where is it? I should also say about the authors. So let's do that. Andrei Kalendarov. Code Forces. I want to just say for every problem who is the author. And that one was what? Dobycia Radia. That was extraction of radium. Can I here put author? Problem author. How to do it, how to do it. I would like to put it next to spoiler on the right, but it doesn't work like that apparently. Can I put it in spoiler? Let's see. User. Let's say Errichto for now. Nope, it doesn't. So where to put it?